That was just for testing, sorry. Did any of you see the first question? No? Sorry guys for the lesser space. This was the biggest hall that we could find. If you guys want, you can come and sit on the ramp or somewhere. But you might get a better view. Sorry. I remember we had the same problem last time. Seems like Avishkar has a lot of popularity. Who knew? Hello. Okay, guys, welcome to Avishkar Hyperloop's orientation program. This is for the recruitment of Avishkar Hyperloop 7.0. We'll be starting with a small icebreaker session. We'll be asking a few questions. You guys can just vote and do stuff. Okay, so let's start off. Oh, I see you guys have already started voting. Cool. When did Avishkar first start as a student team? Wow, nice votes. So yeah, keep voting guys, keep voting. Let's see how high the number goes. Nice, nice. Most of you are doing it correct, it seems. Are they correct, Pranav? He's ignoring me. Okay, so seems like most of you are right. Avishkar as a student team did start in September 2017. It was started by a group of students, one of whom was Suyash Singh. He's currently involved with Galaxy, IITM startup. Okay, this is an interesting question. Which competition did Avishkar Hyperloop first participate in? Which celebrity did we meet? Yeah, okay. Keep it up, guys. Wow. I see a lot of Elon Musk fanboys here. No Swifties? No? Raise your hand if you're a Swiftie. Nice. I've been told Osama bin Laden was a great engineer before he became stuff. Civil engineer? Yes. Oh, okay, nice. This is pretty one-sided, so I'm gonna go to the next slide. As you guys can see, we met Elon Musk in the Hyperloop pod competition, which happened in, which was happening till 2019, 2020 maybe? Yeah. So it was happening till 2019. We participated in the Hyperloop pod competition. We met Elon Musk. It was a great experience overall. We were participating against a lot of student teams and companies as well. So it was a great experience. We learned a lot. Competitions like these are where we go and we meet other teams. Because Hyperloop is such a new technology, there are different approaches to it. Everyone takes a different approach to, say, levitation, propulsion, and stuff like that. So it was a great experience talking to Elon Musk. Again, he's also the CEO of SpaceX, or I think he likes to call himself Techno King. I'm not sure. But yeah, so he's the CEO of SpaceX, and since SpaceX works in again space, they do also have a lot. We have a lot in common because we work in a vacuum environment. So talking to him and learning about how to deal about things in vacuum, it was a great learning experience for us.
Raghav, sorry for interruption. Can you guys come in front and don't block the entrance? Like, come and settle up in this ramp. Last year also we did the same. We said, thank you guys.
Even if you join and not able to do much, please ensure that next year we have a bigger hall. I mean, I'll be there, of course. But if someone just came now, this was us at Elon Musk's Hyperloop pod competition 2019, organized by SpaceX. Next question, guys. Which of the following did Avishkar meet last year? Sitharaman, Piyush Goyal, Narendra Modi, Ashwini Vaishnav, and all of them. What are your guesses? Wow, Modi's getting a lot of supporters. Who knew? Come on, guys, keep voting, keep voting. Interaction with all of these people from the government is also a great experience for us because they give us a lot of they give us a lot of experience in other avenues, right? Because because we are working on such a large project, so they have experience in other domains which help us a lot. Okay, I'm gonna go to the answer. Uh, yeah. So as you can see, this is a photo of us with Narendra Modi. This was sometime last year. So he came for the inauguration of Vande Bharat, and we had met him in that train. The train, as you can see, is Vande Bharat. We went to the station, we climbed up the train, we met with him. Saw the Vande Bharat firsthand. So you all must be thinking the answer is Narendra Modi, right? It's not. The answer is all of them. We actually met all of them last year. All of them actually. Nirmala Sitharaman, Piyush Goyal, Ashwini Vaishnav. We met all of them. I put this picture in a bit of a hurry, so don't mind me. 91 likes, that's good. Oh man, should I have waited for 100? Okay. What is the name of the pod that we took to EHW this year? Let's see what you guys can come up with. Oh my god. Know the answer, guys? Curve. Interesting. Pod. I thought that was kind of obvious, but shut up. No. Hell. Whatever works for you, boys. APK, it seems. Jesus, that's a nice one. You guys are really horny here. Jatayu. Vishnu. Raghav Subramaniam. Guys, that spelling is sadly wrong, but I'll take that. Whoever put that skull face, I didn't know that was possible, so thank you for telling me that. Guys, we are YouTube streaming this, so please be a little kind on us. Kanye, I see Kanye. Nice. I see the director's name up there. Who knew? The number of likes is at 169. I should have stopped there, but anyways. Oh, okay. You guys can type your answers in for this, but for those of you who don't know, our pod names, the name of our pod this year was Garud. You guys are going all out on this one, aren't you? Okay, now that you guys have had your fun, I'll have to sadly go on to the next question. I think I have one more of this coming up. Not sure. Oops, wrong button. Yeah. It's the last one I said. I swear, it's the last one that I said. At this point, I don't even want to turn around and see it. Cool, guys. I have to continue. Sorry for this. That didn't work. That is not working. Seems like the software is with you guys. Okay. A couple of serious answers here. Avishkar is building a very long vacuum tube. How long do you think it is? Take a guess. I mean, 0 to 500 is a very... No, fam. Not yet. We will be making one soon enough, but not yet. Sorry? Units. Okay, this is in meters, by the way. Sorry. We don't have the money for 500 kilometers yet. I see that the scale is going towards 500. That's good. Are you guys not entering more values, or has it just stopped? Okay, it is moving slightly. How many of you think it's 500 meters? Can you raise your hands? Nice. Small number. It's actually not 500 meters. Didn't hear that. 400? 300? 400? No? 50, no. 50 would have been a very small step. We have a 30-meter track here, so 50 would have been a very small step. The correct answer is 400 meters. We are building a 400-meter vacuum tube. Where on campus have you seen the construction happening? C5 still dominates, guys. Priorities. For those of you answering genuinely, think about it. It's a 400-meter long vacuum tube. I can see a few front row guys are Googling. Good job. Mandakni? No, sadly not. Vertical? No. Okay, the answer is it's not on campus. There's a Tayur campus of IIT Madras extension that is outside of Chennai, somewhere a little outside, yeah? Sorry? 35 kilometers from here. Nice. I didn't know that earlier. Which company is sponsoring the 400-meter tube that you're building? Oh my God, that's going to happen again. I got to stop putting this, man. I got to stop putting it. Guys, this is becoming way too vulgar for a YouTube stream. I'm going to have to sadly move on. The correct answer, can anyone shout that out? Sorry? Weird. Okay, so the correct answer is Indian Railways. I heard it somewhere. It's not a company. That was again a trick question. One, man. Okay, this is a picture of us with Mr. Ashwini Vaishnav. He also came last year. We talked to him. We interacted with him. His contribution is quite a lot to our team. We have a lot of support from the Indian Railways for building the 400-meter tube. Oh, man. Okay. I think I showed the answer. That's okay. How much do you think the pod made by Avishkar this year weighs? Yeah, you saw the answer. You didn't? You didn't? No? Sure? Guys, the correct answer is 420 kgs. It's lighter than the heaviest human, apparently. I did not know that. 2/3 of the weight, incidentally. How much do you think our pod cost this year? Zero. 0,000. Subhash. Who's Subhash? Guys, the correct answer is it is priceless. We put a lot of our blood, sweat, and tears into this pod. That's the price of this pod. At least that's what the business team wants me to say. The actual price is 80 lakhs, it seems. Yeah, it's that costly. We have a lot of very, I wouldn't say pricey, a lot of components on the pod that are designed by us and manufactured for a singular purpose. So that takes up a lot of price, and the pod is also big. So the shell, the chassis, all of that takes a lot of cost to make. How did this come again? Oh, I did not go back. Okay, which subsystem do you think is the coolest? For those of you who don't know, there are 8 subsystems that we had last year. Power electronics, embedded systems, infrastructure, business, mechanical, levitation, propulsion, thermal. Oh my God, a lot of levitation fans. I can see the lab guys getting excited. Come on, guys, a bit more support for embedded systems. Please. Man, levitation is like that game called Chain Reaction. You're just exploding. I can see we have a clear winner in levitation, so I'll move forward. Join the subsystem I lead. Embedded systems, that's the subsystem I lead. Was that relevant? Come on, guys, make me win, guys. Don't do this to me, please. Let's go. Near margin, small margin, I'm winning. I'm winning. Day. I better win. I'm going to stop this before that no goes. Okay. Oh, nice. I guess that was the end of it. I would now like to call one of our Avishkar heads this year, Mr. Pranav Singhal, my dear friend, to come and present the main presentation. Thank you, guys.
Well, imagine a world where travel isn't just about reaching the destination, but about experiencing the journey itself. A world where boundaries of speed and innovation are pushed beyond what we thought possible. Welcome to the future of transportation, where we are not just passengers, but we are pioneers, engineers, and dreamers of the Avishkar Hyperloop. Close your eyes for a moment and envision a sleek pod racing through a near-vacuum tube, propelled by technology that defies conventional limits. Now, open your eyes to reality, that this isn't science fiction. It's the groundbreaking work that we do right here. In the next 60 minutes, we'll delve into the intricate subsystems that make up our Hyperloop team, from propelling the pod at incredible speeds to ensuring a comfortable and sustainable ride. Every piece of the puzzle matters, and every challenge presents an opportunity for us to excel. But here's the most exciting part. The journey we're about to embark upon is not reserved for the privileged few. It's an open invitation to all of you, the dreamers, the thinkers, and the problem solvers. We are not just looking for team members. We're looking for the next generation of visionaries who will shape the future of transportation. So, fasten your seatbelts, because what you're about to experience is more than just a presentation. It's a glimpse into the world of Avishkar Hyperloop, where the impossible becomes the achievable and where innovation knows no bounds. Welcome to a journey that's out of this world. Welcome to Avishkar Hyperloop's orientation program. Jay?
Okay. So before I start presentation, I'd like to ask, what is Hyperloop? Like, I want you guys to answer. Can you pass the mic? Those who will answer will get preference in application, by the way.
I hope you're joking. But sure, why not?
I hope. I don't
You hope? Uh-huh. Who wants to answer? Anyone? Raise your hands, please. What is Hyperloop? What do you know about it? Anything. Any small thing. Sorry, guys. Really sorry.
It is an advanced transportation system which uses vacuumized tubes for its transportation with pods inside. The basic thing, like the basic idea for Hyperloop was to minimize the two main factors which affect the general transportation, that is air resistance and friction. But over the course, many changes and developments happened in that field of technology.
Please ask his name.
Man, I mean, you wanted him to give the mic back to me and me asking his name. Okay.
My name is Priyadarshi Anupubare.
Please note down his name. I'll give it.
I'm first
still-
year, by the way.
Okay. It's still next year. Don't worry.
Someone came prepared, huh?
You guys still have chance if you want to answer.
Yeah, anyone else? Anyone else feeling confident? Where? Oh my god. Thank you, sir.
Going to replace aeroplane technology. Air travel will be replaced by Hyperloop if it works properly.
Whoa, someone has a vision. Nice. Anyone else? Anyone else? Only two answers. No? No? Oh! Front bench. Sorry. Oh, again.
Aiming to achieve higher speeds at lower consumption of power.
Sorry?
Aiming to achieve higher speed of transportation at lower power consumption.
Yeah.
Higher speed. That was a nice one. Can anyone take a guess on that speed? 6,400 kmph. Man. You want to leave the Earth's orbit or what? 1,000? Nice. 1,200. That's a nice estimate. Speed of light. Okay, bro. Full science fiction, huh?
This technology reduces time of travel tenfold times. Like 2-hour travels can be done in around 20 minutes. And people living in another city can work in a completely different city. And this will have no problems related to time.
Nice answer.
Ask his name also.
Ask it?
Name.
Name. Yeah. Samarth. From? Mechanical first year.
Don't worry. Next year.
How many first years here, by the way? Can you just raise your hands? Wow.
Oh. Out of.
Nice. Cool, guys. Nice and through. Second years? BTech. Again, good population. Masters, PG students? Damn. Good.
Okay. So now what is Hyperloop? Hyperloop is basically comprises of a levitating pod which can accommodate passengers and have contactless propulsion, and a track which can support levitation and contactless propulsion, and a vacuum tube inside which all this track and the pod is kept so that there is no air drag. Now when you add all these things, you get what is called Hyperloop. So here is one of the video of working Hyperloop. This is an Indian version of Hyperloop. Okay, so I'm just kidding, this is not Hyperloop. So in Avishkar, our team is divided into 8 subsystems, which are levitation, traction, power electronics, embedded systems, thermal system, mechanical system, infrastructure, and business. So, by the way, I am from levitation. So, in levitation on our pod is done using electromagnets. So, we have electromagnets for both vertical levitation as well as to guide the pod laterally. So, what is EMS? EMS is basically, it consists of a ferromagnetic track and an electromagnet. So, when we excite the electromagnet, it gets attracted to the track, and the electromagnet is attached to the pod. So, when it gets attracted, the pod moves up. Here is one of the example of electromagnetic suspension in action. So these are the EMS that we have designed in-house And we have separate EMS for both vertical as well as lateral levitation. So for vertical, we operate at an air gap of 6 mm, and we can generate a maximum force of 1200 newtons. And for lateral EMS, we operate at an air gap of 6 mm. So here is a control architecture that we use to control the current through our EMS. So we basically use nested loop PID controllers with current PID and position PID. So we control both the current as well as the air gap between the EMS and track simultaneously. So to test our control architecture, we have designed different setups. So this was the first setup that we designed. It's called 1 degree of freedom setup. In this, the EMS is constrained to move only in one direction. So when we pass current through our EMS, it gets attached to the track and it moves only in vertical and it moves only like down and up. Here is the graph that we got when we were testing our 1 degree of freedom. So as you can see, we went from air gap of 12 mm, initial air gap of 12 mm to 8 mm, which was our equilibrium air gap. And as you can see, we gave disturbance also, and it was quite stable. It came back to 8. Now I will hold on to my friend Suman, who will explain further setups.
So Jai told you how to control one magnet, but you can't expect to lift a Hyperloop pod with just one magnet. You need more. So how do you control multiple magnets at once? So we built another test setup, the 3 degree of freedom test setup, which basically is a scaled down version of the pod. It has 4 electromagnets at 4 corners, and each of them are controlled separately. So here's a picture of the 3 degree of freedom setup with hairy legs. This is a video of it working. So as you can see, there's no contact between the setup and the track, and you can freely slide it. So that's it for 3DOF. Next, we built a lateral test setup, lots of test setups. So the lateral setup is basically for testing lateral stability. It has 2 lateral electromagnets and 1 vertical electromagnet so that we can test both lateral and vertical together. So this is something we'll be working on this year. And as for the goals for this year, we'll be researching on HEMS, which is another type of levitation. It's called hybrid electromagnetic suspension. We'll be conducting research on magnetic drag force that's created during dynamic levitation. And we'll be focusing on thermal management of the EMS coils. And obviously, we'll be trying to levitate the pod because, you know, when you don't levitate the pod, people say shit like this.
Hyperloop is basically a train.
It's not a train. So what's in it for you? Why should you join levitation? Looks like you guys think levitation is the coolest subsystem that's there. And you'll be working a lot with control systems. So and also you'll get to interact with professors, experts in the field, and not to mention you'll get to work with me. And you'll learn lots of softwares like MATLAB, ANSYS, Simulink, Fusion, blah, blah, blah. And I don't know, you can do whatever this guy is doing here. Yeah, so that's it for levitation. Now I'll hand it over to traction.
Hyperloop is
Guys, give us a minute. Looks like levitation was too much for the laptop to handle.
Who's hacking it, guys? Tell me your name, I'll take you in for the coding part directly. It's back? No? Yeah, nice.
Okay, so coming to traction, we have three main things to work on. First is the propulsion of the pod. One is braking and the control of the speed of the pod. So you can see the LIM, which is mounted in the between of the pod, and there are two braking actuators. So while designing the LIM, we have two main design choices. One is the winding choice and the geometric choice. So test setup for DLIM. We achieved 1,000 RPM using the test, and the operating voltage was like 48 volts, and these were the parameters. And this year you will be working on SLIM, which will be used for high-speed testing, and it will be useful for analysis of lift forces. So coming to motor controls, we have employed volts per hertz control for the LIM. It is completely in-house developed, and we have tested the framework with stress testing. So what's in it for you? You'll be working on different CAD simulations and other simulation tools. And you'll also be working on different motor control methods like V/F, vector controls, etc. And you'll also interact with many industry professionals and professors. So the goals this year will be to research and implement the regenerative braking and implementation of vector controls on LIM. And you'll have to research on LIM and different methods of propulsion and scalability of propulsion systems.
Hello everyone. My name is Namasvi. I'm mechanical engineering third year. So, I think now you have a basic idea on how our levitation and propulsion systems work. But how do you think these systems are getting powered? How do you think these systems are getting controlled? This is where the power electronics subsystem comes into action. So, in the power electronic systems, we design the electronic systems which are required for the pod. But for the prototype which we design, the power requirements are not really that high. But for a full-scale levitating Hyperloop pod, the power requirements are obviously very high. So we design our systems in such a way that they're compatible with these full-scale systems. And also, one more requirement is that these electronic systems have to be compact and light, such that the cargo and the passengers, we could provide more space to the cargo and the passengers. And also, at the same time, we should ensure that utmost safety is present. So this year in power electronics, we worked on three main things: the batteries, the inverter, and the DC-DC converter. So first, the batteries. So yeah, the batteries. First, we have the primary battery pack, which is the high voltage supply to the linear induction motor and the electromagnetic suspension. This battery pack is made up of lithium iron phosphate cells, in short the LFP cells. These cells are laser welded and are hexagonally arranged for maximum packing efficiency. This battery pack is capable of providing a very high voltage, around 300 volts, and a power capacity of 60 kilowatts. So coming to the auxiliary systems, like the sensors and all the control units which are present on the pod, they generally operate at a very low voltage compared to the LIM and the EMS which are there on the pod. So to meet this low voltage requirement, we have one more small pack on the pod, which we call the secondary battery pack. This provides the low voltage to these auxiliary systems, which is of around 25 volts. So as you can see, all the things, the LIM, the EMS, the sensors, and the control units, all are powered by these batteries. So basically, these batteries are the components which bring the pod to life. Moving on. we have a variable frequency, variable voltage inverter, which sends three-phase voltage and current to our linear induction motor. It also facilitates us voltage and control, voltage frequency control. In short, it is called as a V by F control. On our LIM, we use this. Then this inverter is completely custom designed and in-house built. It is highly safe and is scalable with almost an efficiency of greater than 95%. It also has a custom control card, which is completely designed by our team, which controls the working of this inverter. So not only you get to work on electronics, but at the same time, here you can work on designing the PCBs also. Then moving on, in the levitation part, you guys might have understood that there are 4 vertical EMS placed on the pod. These vertical EMS are these vertical EMS are controlled basically, which depends on the current flowing in the coil. So this control is done by the DC-DC converter which are present on the pod. These DC-DC converters, 2 DC-DC converters are there on the pod, which are placed on either side of the pod, which control 2 EMS each. This DC-DC converter works on half-bridge topology. This is also custom designed and in-house assembled. Each DC-DC module has a custom control card which controls it. So simply put, these are the 3 things which we worked this year. So moving on to the goals which we have this year, we are planning to research and implement regenerative braking on our LIM. This is something which traction and electrical will be working together. So what is regenerative braking? In simple words, when you are trying to brake the pod, you get the pod almost has a zero kinetic energy. Like there is a lot of loss in the kinetic energy when you try to bring the pod to the stop. So this loss in the kinetic energy is converted to the electrical energy and is stored back in the batteries. So like this, you can save some amount of energy in this braking method. So, and also we are planning to design a safe and compact inverter for the efficient control of a motor this year. And then as there are EMS present on the pod, there are some stray magnetic fields which are present, which interfere with our electronic systems. So in order to prevent this, we want our systems to be tolerant to these interferences. So that is something which we want to work on this year. And at the same time, you guys know that Hyperloop runs in vacuum. So it is highly important to have vacuum compatible electronic systems at the same time with efficient thermal management. So these are some things which we worked on this year. So we have a lot of opportunities for all academic disciplines, starting from BTech, MTech, MS, and PhD. So we highly encourage everyone to apply. Now I would give to my friend Raghav to start the sense and control subsystem.
Hey guys. Looks like I'm back. Okay. The embedded subsystem, right? So starting off, I would like to tell all of you that the embedded subsystem is the safest subsystem on the pod. Whenever we make mistakes, we are usually safe. It's the people from other subsystems that we kill. To begin, the embedded system works on a lot of stuff, right? So almost the entire branch of electrical engineering is covered in this. We work on communications and embedded design, not chip design, I would say, but working with various chips that would require a good knowledge of digital design and analog design, and almost a big set of electrical engineering is covered. Starting off with CAN. CAN is a form of communication that is used in vehicles and aeroplanes and a lot in the automotive industry, I would say. Right, so CAN communication, as you can see there, we have various PCBs on the pod, the navigation control unit, the main control unit, the levitation control unit, the propulsion control unit. All of these need to communicate together, and it's the job of the embedded system to have a good integration between all of these modules. CAN is our main mode of communication between these modules. We use it for data transmission and signal actuation, all of which has to be done in real time and is very important. Right, so We do have a main control unit, as you saw on the previous slide. The main control unit runs a RTOS-based code, which is important because it makes the code more modular, and the parallel processing helps us a lot because you can have faults from anywhere, right? So identifying faults, acting on it. We have a very comprehensive state diagram that we follow. Okay, this fault appeared here, we have to fix it that way. So implementing all of that with RTOS is easy and efficient. PCB and circuit design. Again, an important part of what we do are PCBs, the PCBs and the circuits that we make. They have to be fault-proof and they have to interact with a higher voltage, right? So doing that is difficult, and accommodating all of that is done by the PCBs and the circuits that we make. Most of our batteries have a 24-volt supply, and controlling components like contactors and braking and all of that is done by the PCBs and the circuits that we make, right? Our pod is supposed to run at, like you guys said, 1,000 kilometers per hour, or 64,000 kilometers per hour, like someone said. But our pod is supposed to run at such high speeds, and our controls have to be that fast as well to respond real time, right? We have very little air gaps, as they mentioned, 6 mm air gap. If some fault occurs there, we have to act immediately. So all of this is made efficient by our PCB and circuit design. Linear encoding method. I should have mentioned velocity there somewhere. Okay, novel method of velocity calculation. So why is velocity calculation important? And why are we doing it differently in our case, right? So like you guys know, our pod runs in vacuum in a contactless manner. The tube that we use is, can I say that? Okay, it's supposed to be a steel tube. So in the steel tube, transmission of signals from the inside to the outside is, it can't happen because the tube acts as a Faraday cage. So we cannot use conventional methods of velocity calculation like rotary encoding or GPS based, right? So these constraints have forced us to come up with a new method of velocity calculation. I won't say it's new, but the implementation of it and making sure that it works in our case. That is something that we have done. I can't say more about this because there's a question in the application, so I'll move on. Okay, the GUI. Well done. Okay, so the GUI is something that we have designed on our own. Right. Why is the GUI important? In normal scenarios, our pod run autonomously, right? It makes its own decision, it collects data, and based on the data, it decides if it wants to propel forward or brake or whatever. All of that is taken care by the pod autonomously. But at the same time, all of it is also communicated back to the base station. In our case, that's a laptop, right? So whenever the pod is running, we constantly monitor all values and make sure that there's nothing going wrong in the pod. And if it does, as you can see, there's a command station there on the right, so we can stop pod and we can do a lot of stuff. We can also run the pod manually. Developing the GUI was something that we did this year. What can you expect from us? Okay. We work with basic analog circuits and we bring simulations to life. All circuits that we make, we simulate it first. We make sure that they cover the breadth of the cases that we might encounter. Designing amazing and cool PCBs that work most of the time. As you saw a couple of slides back, we do make circuits. And it is very important that we make them efficiently. So all of that is done by ourselves. We use a software called Altim for it. Working on new methods of velocity calculation that are unique to the Hyperloop's environment. I've discussed this. Writing clean and robust code which makes the pod run truly autonomous. Right? So the code that we write, it has to ensure that the pod run is autonomous. Currently, we are working on RTOS-based code. That might be the case next year as well. So you'll be working on that. And if we do go on to an OS-based design, you can expect to work on that as well. Working in depth with processor architecture and getting a good grasp on digital design. right? So this is important because we'll be trying to ensure this year that our code is more robust, right? For that, we'll have remote debugging and remote code uploading and all of that. Working on that will require a good grasp on digital design, understanding how the processor actually works. Till now, most of you might have been working with hobbyist boards like Arduino and Pi, and going forward, if you consider working in Avishkar, you will be working in depth on the processor itself, understanding how it operates internally, where it fails, and stuff like that. Okay, that brings me to the end of my slides.
So, hello guys. How are you doing? You are fine, so I am also fine. So, I'm Saket from the thermal systems. It's a cool picture. So, why do you think we need the thermal subsystem? So, first thing you can see up there, it's some news articles about electric vehicles going wrong, they're catching fire. That's because, they don't have proper thermal management systems. So basically, you have any electrical system or a device, it's not 100% efficient. There are losses, and the losses are in the form of heat. So basically, when you have heat which is not addressed, heat builds up in the system, the temperature increases, and as the temperature increases, the efficiency of the system decreases, and due to the efficiency decrease, there's more heat produced. So that's a vicious cycle which is called as the thermal runaway cycle. And if you don't address heat at some point of time, it's going to become like that. So, yeah. So when thermal doesn't work, it's basically explosive. So coming to thermal on the Hyperloop system. Basically, we have had our three cool technologies which they explain: levitation, traction, and the power electronics. They're all very cool technologies, and I agree. But once they start working, they won't be cool anymore. So basically, we have some common cooling technologies which are there in the industry. You can see them up on the screen: phase change cooling, radiative cooling, refrigerative cooling, heat pipes, air cooling, and impingement. But are they, can we implement them on the Hyperloop? Well, actually, you can't directly implement them on the Hyperloop. How are we different then? Firstly, we have the vacuum environment. So you could just argue that, Hyperloop is similar to maglev. It's levitating and, levitating and running at high speed, so you can just use the thermal management system of the maglev and put it up here. But no, maglev doesn't run in a vacuum tube. So we have a vacuum environment over here, so we can't dissipate the heat which is being produced directly into the atmosphere. One way you could do is to store the heat and then dissipate some after the pod run is done. Or maybe you could dissipate heat in the form of material. So that's some insight for you. So we maybe need a bit more than the convention cooling technologies. Oh, sorry, a lot more, because the heat dissipation from our coolest technology subsystems are like of the order of few watt per centimeter square. So that requires some innovative cooling technologies, which you guys will be implementing, So yeah. So thermal subsystem prevents the pod from being hot. What did I miss? Oh, sorry. I'm sorry. Yeah, common techniques don't work for us. We need more than that. So how is the work at thermal subsystem? What work do we do? Or what work will you be expecting to do? The first thing is, we'll start off with an idea. I don't know how that got missed in the slide. So yeah, first you'll be starting with an idea. Then you take the idea, make a design. You'll run lots of simulations using that. Simulations on softwares like Fluent or COMSOL, things like that. And once you do the simulation, you get data out of it. After you get the necessary data and you're satisfied, you go on to building the experimental setup or the prototypes. Using prototypes, you conduct experiments. And using experiments, you again gain data. Then, after that, you get data from both the simulations and the experiments. You keep both of them and validate the experimental data. And once everything is done, you implement them finally on the pod. So basically, what are the goals for thermal subsystem? You could say all of the other subsystems mentioned that they want to cool their things. We want to have a stable working temperature, and we want to prevent the thermal runaway from happening. So that's the basic goal. So last year, what we did was we worked on 2 to 3 technologies, one of which was immersion cooling, which you can see on the screen. I won't go much into the technical details because you'll get bored. So we worked on the immersion cooling, another technology called microchannel cooling, and phase change materials. We did some research, and we had built successful prototypes which showed that a stable temperature could be achieved. A stable or constant temperature could be achieved. So this year, we want to implement them on the pod. So what can you learn or what do you expect to learn? What can you expect to learn out of this? Firstly, you'll be conducting thermal analysis of on components. You'll be working closely with concerned subsystems, being the traction, levitation, and the power electronics. Thirdly, you'll be doing lots and lots of simulations, mainly on, I don't know why it's not put there, mainly on ANSYS, COMSOL, and other softwares. And last but not the least, you'll be doing some dangerous experiments. So yeah, the coolest engineers solve the hottest problems. With this, I give it to my friend Vishwa to go on to the mechanical systems.
Hello everyone, I am Vishwa from Mechanical Subsystem. So in mechanical, we mainly focus on the chassis of the pod, the emergency braking, and the emergency suspension, and the aerodynamic shell. We also work on integration of all the components on the pod. So coming to the chassis, we designed a simple inverted U-shaped chassis made of a sandwich structure. The sandwich structure consists of a composite layer on top and a honeycomb structure in the middle, and again a composite layer below. And since the honeycomb structure can't be bent 90 degrees, we used PU forms at the bends. So we did a lot of simulation in this tenure. I spent about half of my tenure doing simulations. We fine-tuned this design, and finally we made a chassis which weighs about 19 kgs. And it can bear a load of 400 kgs, and it could also take the loads of traction and levitation. Next is the aerodynamic shell. We went through multiple iterations of design and finally arrived at this design of the shell. We performed multiple CFD simulations to optimize the design and come with a minimum drag value. Next is the emergency suspension system. We have a vertical suspension which takes the impact load in case vertical levitation fails. And we also have a lateral suspension which is important for the lateral stability if the lateral EMS fails. These suspensions are designed such that it is compatible with the levitation. Next is the emergency braking. We use friction brakes as emergency brakes, and you can see the friction pads going and touching the track to stop the pod. We require a lot of force to stop the moving pod, so we use efficient and a compact pneumatic circuit which we assembled in-house. Next, as I mentioned before, our main goal is also to integrate all components on pod. We designed casings and holders on pod. We designed casings for hot electrical components such that they are made into modules, which is easy for access and doing multiple pod runs. So our main goal this year would be to work on the last year's work and improving it and move a step forward to vacuum compatible Hyperloop pod. So what can you learn? You get a lot of experience and knowledge in designing CAD models and doing a lot of simulation. Your work would be like making a design, simulating it, and fine-tuning it, and again changing the design, and again simulating it. This will go on until you get a near perfect design. So you will get proficiency in softwares like SolidWorks, Fusion 360, ANSYS, COMSOL, and Adams. And you will also get a lot of hands-on experience and a very good knowledge. Thank you.
Hello. So as you have seen all the subsystems of the pod, now comes the part of infra. Sorry, infrastructure is a very long word. That's why I'm saying infra. So here comes the infrastructure subsystem. So my name is Pranav Sapkure. I am the civil engineer, second year student. Second year only civil engineer student in the whole. Oh shit, third year. I just passed into third year. Sorry. So I invite you all to see our pod run in this PPT. So apart from this, let's move forward. Aur ek baar. Okay, leave that. Let's go forward. So as you guys have already said, someone from near that guy, Hyperloop is based on two concepts. One is minimizing air drag and second is minimizing friction. My friend from levitation teams have already discussed with you how we are minimizing the friction, and I am here to discuss how we are minimizing the air drag. So this is the vacuum tube. Inside this, there would be vacuum. But what's special with this? Baja lo bhai tali. But what's special with this vacuum tube? Even a tiffin box like this comes with a vacuum seal. Why do we need to research on the vacuum tube? So before telling you that, let's see the case study of, can anybody tell what is this? It's a maglev train. So it was a pretty advanced, it's a concept similar like Hyperloop, but without vacuum tube. Apart having advantage over the high-speed rails and other technologies, it's still not like fully developed and can't be developed because of its infrastructure cost. So it's all about the money. So by joining the infra team, you would be the one who would actually build the dream of Hyperloop, an actual Hyperloop day-to-day service. So what includes the infrastructure of a Hyperloop? One is the already hamara dabba. Second is the track, which will support the levitation, braking, and the propulsion. Third is the civil structures for supporting the tube. And fourth is the vacuum systems for maintaining the vacuum. So as you can see from this graph, the infrastructure accommodates almost, excuse me, where are the percentage? Design team? Consider it approx 80%. So apart from that 80%, around 45% of the of that infrastructure is occupied by the tube in terms of cost. So designing a cheap Hyperloop tube, not a cheap, economical and scalable Hyperloop tube, comes with this many problems: buckling, ovality. Sorry guys, I don't have the time to explain you what these terms mean. Join the infra team. So for designing that Hyperloop tube, which would be economical and scalable, we do multiple simulations with a systematic approach. You can see from this paper, this is our paper on that design process. But how would you know that whatever you are designing through the simulations is correct or not? Experiments. So these are the two destructive testing performed by the infra team in IITM itself. If you come near C5, you can find this Titanic submerged somewhere. So let's move forward. So what is the result? The result is that we were able to reduce the cost by 45% of the conventional tube designs which are used by major companies like SpaceX, Virgin Hyperloop, and other companies. And what we say to them. So whatever we have done is just the one pillar of the big castle. And we have more pillars to build. So these are the upcoming pillars we are going to build. One is the completion of our 400-meter Hyperloop testing facility, which would be in the Thayur campus of IIT Madras. Second is building a 50-meter custom track concrete tube facility. As my friend Raghav has some problem with the steels due to its communication, apart from that, the concrete will reduce the cost much more than the existing steel tubes. Third is integrating the gating systems in the 400-meter tube. So this is the GIF of what we are trying to do in our gating system. So fourth is the lane switching and turning for Hyperloop. And fifth is designing scalable vacuum systems. So you can see in this photo, this is our current site photo. We have already developed foundations and pylons, and we are targeting till December, this whole Hyperloop facility would be developed and present in the Thayur campus of IIT Madras. And if you be the part of infra team, you would be the one who would actually handshake with the big personalities like Prime Minister, Railway Minister, and other person. So what's in it for you? You will be proficient in ANSYS, Fusion, MATLAB, and other softwares. Practically doing what you design through the computers like we did, and test it what you want. Interact with industry experts, academic scholars, government officials. And we have a partnership with L&T in developing that infrastructure. You would have, in that picture you can see L&T's logo. So yes, we have collaborated with major companies like L&T and Tata Steel. Patents and conference paper. We have 3 patents, and we have attended one conference in Mumbai. And you would have an amazing and unique journey. And you will never, after even completing your tenure, you would be here like our heads to support us. Hello. So this completes the infrastructure part.
So up till now, the subsystems have presented how they work, what they work on, and I presume you might have got a gist of their efforts in making up a working Hyperloop system. But what's the point of these efforts if there's no one to show them to the world? For example, as many people stated, they met that minister, this minister, but how do they, the ministers, know about us? So that's where the business team comes in. Yeah, that's where the business team comes in. Next slide. So as it says, if Avishkar in its entirety is an interface, the business is the front end. So if anyone's interested in web development, they can relate to this. So good evening, everyone. I'm Sriraj, a third year BTech undergraduate from the Materials Engineering Department, co-heading the business team with my friend Sarthak.
Hi guys, I'm Sarthak from third year Metallurgical and Material Sciences. In case you feel like following me, this is how I look from behind.
Yeah. So how do we do what we do? So we have a lot of verticals under our subsystem. One is branding and outreach, where we call ourselves the most creative unit of the team. We upload posts. We keep our social media handles engaging with wacky posts and catchy phrases. And we also design the cool merch that you see, like the ones wearing, sitting there and wearing. And yeah, we also do design cool jackets. So if you're in the team, you get to wear them. And by the way, the tremendous efforts of the team made ourselves into great positions in the competitions, as stated. That led us to developing a great media featurette. So as you can see, we were featured in all of these media agencies. And due to this, we also got contacts to various journalists, etc. Moving on, we have finance.
So handling the budget of few crores is a difficult task. So for that, we need a better management to handle the budget. We are involved in the accounting and management of the whole budget and budgeting the whole. Sorry for that. We are actively involved in taking an active participation in raising purchase orders, renders, and reimbursements. So as you can see in the meme, I'll have to explain it. So we, the finance vertical, roam around asking for the team to give us the invoices so that we can process the reimbursements.
Business is so advanced that we have to explain ourselves to meme. Yeah. So coming to the next one. So to deal with money, we need first money. So to bring that money, we have our sponsors. So the business team deals with the end-to-end process of bringing sponsors on board. For example, the 6.0 team had the sponsors Indian Railways, Tube Investments India, and Pickstone Images. And these were our past sponsors, without whose support we won't be here, we won't be the team who we are. So what if we don't get any sponsors this year? Next slide. So yeah, you will get your answer. So yeah, by the way, that's our head Pranav Singhal sitting. So that will be our situation if we don't get any sponsors. Yeah, moving on. Logistics.
So we have our 400-meter vacuum tube coming up at the third campus of IIT Madras. So we had a huge demand for steel, aluminium, and concrete. So the logistics team mainly works for procurement things. We work along with other subsystems like mechanical, infrastructure, and electrical to get on-pod requirements. During the procurements, we need permission from high authorities of the institute, like director, CSO, anyone. So you get direct contacts of them. This is the current situation of logistics team. Next vertical is research. So we have introduced the research vertical this year. Avishkar is working on technologies, but it's important to note if the general population of India is willing to accept the Hyperloop or not. So for that, we do research to check the feasibility. Last year, we did research on the topic social and economic aspects of Hyperloop in India. And the conclusion were pretty good. And we came to the conclusion that it mostly would be feasible by most of the proportion of India. We presented our research at the European Hyperloop Week held at Edinburgh, and we were nominated in top 3.
So when I said business is advanced, I'm not joking. One proof is that coming up top 3 in our socio-economic round in EHW. So similar to EHW, one of our team goals and business team's goals for that matter is to host a global Hyperloop competition wherein we will be using the upcoming 400-meter track and 400-meter vacuum tube as a functional component for the international teams to run their pods in. And speaking more about global Hyperloop competition, it's a secret. But rest assured, there's a lot in store for them. You'll have much more opportunities regarding global Hyperloop competition. Moving on. Yeah, so what's in it for you? I'm sure you can read all of this, but if you speak about myself, I joined the team as a business subsystem member. So I myself learned a lot of software. I learned web development in order to work on our websites. And also, if you are interested in finance, you will deal with a great level of command because people come to you for reimbursements, and then you can shut them down if you have any past fights with them. And yeah, we do interact with all other subsystems and gain knowledge of Hyperloop via case studies, as shown previously in the research paper. And yeah, so this year we will also be working on one more research paper. So I'm sure whoever's applying for business is in for a lot of things. And yeah, you'll be working under me. So again, rest assured you're in safe hands. So yeah, that's all from business. Thank you. So you have seen the documentaries of 4.0 team and the 5.0 team. And I think I was the one who said that you will be the first people to have viewed the documentary of 6.0. So here you go.
Every Indian should either become an employer or should work in a place which promotes technology for India.
Center for Innovation is being established with one of our alumni support with the motto of walk in with the idea, walk out with the product.
Avishkar Hyperloop started at the Center for Innovation, which is going to make India a superpower in 2047.
Avishkar Hyperloop is actually creating history in developing the entire Hyperloop stack.
Hyperloop as a concept has 3 things to it. It has the tube, the track and the pod. And up until now we have only focused a lot on the pod. And in Avishkar 5.0 we tried to move away from the pod and try to focus on things such as the tube and the track. Avishkar is a very unique team because when we say a student competition team, it's a complete student competition team.
Avishkar Hyperloop is actually a self-organizing team. Year on year, there will be a set of students that will get inducted. The people who are actually spilling over to the second year will actually become the leaders of the next year's team and expand the team back again.
We have something called a knowledge transfer period in our team. As soon as people are inducted into the team, we spend about 1 or 2 months just teaching them on what all has happened in the previous years. And beyond this, we don't leave them restricted there. We give them full freedom to go and explore out.
Once the team progresses from one term to the next term, the seniors who were in the team don't feel like leaving the team. And even if in the next tenure they are not a part of the team, they do come to the workspace. One thing we saw when we went to ASW is that there was one of the teams which had a very high tube thickness. So what happens when you have very high tube thickness? The material cost increases drastically. And it's an Indian mindset to think about the cost first. So what we did, we found an optimum between the tube thickness and the stiffness. We came from 30 mm to 6 mm, which was quite astonishing.
And we are improving upon it even further so that we can minimize the cost of Hyperloop, so that by the time it actually goes to a commercial scale, we will have the most economically viable Hyperloop technology option anywhere in the world.
So in this composite sandwich structure, we had a lot of variables or parameters that could be varied. Like for example, the faces, the pores, and there were various ply orientations that were used. So eventually, we performed FEA simulations for each of these permutations of the chassis. And then we finally arrived at a U-shaped chassis that could accommodate all the subsystem components on it, as well as be space optimized.
Electrical integration, our main challenge that we faced was to integrate all the subsystems together when they come on pod. So before we put it on the pod, each of the subsystems were tested separately and they were working. So finally when we put it on pod, we had to integrate them, and communication was a major issue.
We solved this issue majorly this year by using a robust CAN communication system, and this has made debugging the system a lot more easier.
A lot of research and literature survey was done in 5.0. Basically, they were weighing out all the options which were available for us to do levitation. They finally chose a mechanism called electromagnetic suspension, which is in short EMS. The biggest challenge when it comes to levitation is the controls aspect of this. Because we operate with such low air gap, which is approximately 8 mm, let's say, the control needs to be highly precise, highly reliable, and very fast. To solve all these problems, we decided to take baby steps. We wanted to solve one problem at a time. So the first thing we did was something called the 1 degree of freedom test setup. So here the EMS is allowed to go only up and down. Our next step was go to something called a 3 degree of freedom test setup, which is much closer to what's happening in the pod. We were successful in making that 3 degree of freedom test setup levitate.
From the previous pod to the new pod, the major changes which we have made is implementation of DC braking. So previously we had been using electromagnetic braking, and now DC braking is a much more effective way of braking. And another small change which we have made is that a way to implement bidirectional mode. 3, 2, 1, start. DC brakes. So we'll change.
It's quite possibly the most diverse subsystem in our team. All the way starting from funding our team and all the way to designing social media and handling all our social media and website pages.
When you collaborate with industries, they have a different perspective to what you have designed. After all, it's our tube, and we want to get it manufactured in the most easiest and the most feasible way. So we decided to go ahead with what was the solution given by the manufacturing company, that is L&T.
Back in 2017, we had started as a fun student team. We often get hit by quizzes and exams, final exams. So we would have just started to pick up the momentum, and suddenly we'd be hit by an exam and suddenly there's no activity. And then once again we have to we conduct a lot of full team meets to bring back that momentum. Have a lot of fun in lab. We could be working on the most biggest project and we could still have a blast doing it.
EHW itself is configured to keep up with schedules. They have several stages of design document submission that have deadlines that the students actually work towards.
By the end of the first week of June, we had actually planned our pod run, but unfortunately, we were way behind in our schedule. That 1 week was actually point when the true Avishkar came outside and the true culture of Avishkar came outside. Nobody from the team had actually slept during that 1 week, and everyone slept. If they slept, only about for some 3 or 4 hours, that too only in C5. One of the first most significant teams of Avishkar is the Avishkar 2.0, which participated in the SpaceX Hyperloop pod competition back in 20.
Immediate one that we can think of is very recently, the Honorable Prime Minister actually found it fit to interact with our Hyperloop team. And subsequently, we have had the Railway Minister spent a significant amount of time with the students, and he awarded the approval of the project to proclaim that he will actually be the 72nd member of the team. He will actually be offering an international competition very soon with a vacuum tube to be part of the entire competition.
I have learned to see a bigger picture and explore the technology in a complete sense.
I kind of taken away that you can really dream big and you can actually make it happen if you have the right people surrounding you and supporting you.
So the entire thing is actually a fascinating story of how students can actually build technology for a nation and the world. And that's happening right here at IDPS.
So, before we end, I have some photos to show you. And I really said, to old members, I was forced to do that. So, here's a photo of team bonding. See, people are feeding each other and enjoying the break time. And here comes head. Ex-head. Disturbing people's sweet time. This suggests what not to do. See, please. You should use protection. And please, don't do yoga while working. These are some memorable moments, when we were assembling the track. Yeah, some sleeping moments. When we work, we don't sleep in our rooms. We just chill in C5. Yeah, this summarizes our participation in ESW 2023. We competed on a global scale and got recognition. That's a huge thing. And this is how our pod looks like. To show off, we have 3 patents and 2 are on our way. Thanks to Ankit Bhaiya. Once more. Now let's come to main thing, timeline. So today you had orientation. Now you want to know about the recruitment process. So tomorrow morning we are going to release the application. And we will give you around 5 days to complete that application. I don't want to say that, but applications are hard. Applications are really hard. So if you just go through application, and if you have doubt, so like if you have any doubt, come to C5. We have planned Ask Us Anything session in C5 from 9 to 12 p.m. in C5. So from 17th to 21st, we will have Ask Us Anything session. And on 23rd August, there will be application submission. Like 23rd is because you have, like your quizzes are starting on 24th. So before that, we want to like wrap up application submission day. And like round 2 is basically like some applications have, some subsystems application have presentation in round 2 and some have interview. So round 2 will begin on 7th of September and mostly like we will finish the recruitment process by 16th of September. So stay tuned for application release. Have a good night's sleep tonight because next 5 days are going to be hectic. Thank you. Thank you.
Guys, we are done with the presentation. We can have a small Q&A session if any of you want. Any questions anyone has, we can answer them right now. Okay, guys, the application is starting from batch 22. Unfortunately, batch of 23 cannot apply as of now. It's not in our hands. But stay tuned, we'll have a lot of opportunities for the 23 batch as well.
We can't apply this year, but I would be interested in doing so next year. So what should I do to prepare over the course of the year?
So for 23 batch, I would say just stay in touch because in coming 2-3 months, we might or we will try to release application for 23 batch.
Yes.
23 UG batch.
Only the 23 UG batch cannot apply. It's a directive from the Dost office. We can't do anything about it. But every PG student is invited to apply. Yes. There is no CG cutoff for any of the subsystems. You are invited to apply as long as you have dedication and you have done the application. You have very good chances. Guys, it is important to note that